4.3, multiplying decimals, areas, and volumes. Well, actually, for 4.3, for areas, we may look at circles as well. Okay, but as far as I remember, we don't require you guys to memorize those formulas. Yeah, so same with volumes. But it's a nice application of decimals because you just multiply, like for a rectangle, right? You'd say, well, what's the area of a rectangle? Where before we looked at rectangles and, you know, maybe this was 4 and this is 5 right here, which was nice. Now it's just, it may be something like 4.2 and 5.1, right? And then you say, find the area just by multiplying those two. In any case, we'll get into it. So with multiplying decimals by hand, what you should do to start the problem is just identify how many decimal place values there are in the problem. Not for one of the two factors, okay? You need to do it for both. So just identify how many place values there are. Then you ignore the place value, or the decimals, okay? Just ignore the decimals, multiply them as though they were just regular whole numbers. And then, once you get that product, then apply the number of decimal places that you found from the beginning. And then, of course, the final thing you're always going to want to do is check your work, which we're going to be doing with the calculator, all right? But basic operation rules apply when operating with negatives. So, remember multiplication of negatives. If there are an even number of negatives, the answer is a positive. If there are an odd number of negatives with multiplication, then the answer is a negative. I think I said that right? Did I do both of them? Yeah. Okay. So, like this one. Multiply these two numbers. All right, so just based on those rules that we looked at, or the process, right, is I look at how many place values there are. So I say, well, I got 1, 2, 3, 4 place values, right? So I'm going to keep that in mind when I find the actual product, which I would do by multiplying these without any decimals at all. So I would make that 522 multiplied by 754, and we are multiplying these. So let's multiply it out. So as a product, this would have been just without decimals, right? We're looking at 393,588. But then we go back to the place values, which is 4 of them, right? 1, 2, 3, 4. Well, I need 4 place values, 4 decimal place values in my product. So I apply these now that I have a product. And I always start with the number farthest to the right. 1, 2, 3, 4 place values as decimals. So this final answer ends up being 39 and 3,588 ten thousandths. Now again, that's assuming I did this math correctly, but let's take this to the calculator and check. So the calculator has confirmed that we did that correct. So there we go. So see if you can do the same process on this one. Now this one looks a little different, but again, the process still applies, all right? So see if you can do this one. I'll give you guys 1 minute to see if you can do it by hand and then check on your calculator, all right? 1 minute, go. All right, you guys, let's go over this one. So again, the first thing, I'm just going to identify how many decimal place values there are. I see 5 of them, all right? So, and now we're going to multiply these, but without any decimals, which would just make the first number 35. And the second one would only be 55. Now, I know it's 55 ten thousandths right there, but again, I'm not worried about the place value as much as how many decimal place values there are. So multiplication of these two is not too bad. 5 times 5 is 25. Carry the 2. 5 times 3 is 15. Plus 2 is 17. Now we're in the tens place value. Should get the same number. 175 there. So I'll add these together. 5, 12, 9, 1. So my final product here is 1,925. But again, I need from the green how many decimal place values there were. 5 of them, right? Now in this case, I've only got 4 numbers. So what do? Well, I need 5 decimal place values. Where I only have 4, I can just create a 5th one by putting a 0 right here. Okay. So the final product on this one ends up being 0 and 1,925. But this is in the hundredths. I'm sorry, the 100,000ths place value right there. And again, going back, right, because we need to apply just general rules for multiplication of signs. And on this one, there was one negative being multiplied. One is odd, so we know the answer is a negative. Negative 0.01925. But again, we'll just put this in the calculator just to double check. So I put it in there. It shows me the answer that we have, negative 1,925 hundred thousandths. So we're good to go on this one. All right. Same concept on this one. So again, I notice on this one, and it doesn't matter when you apply the rule, just make sure you do it with the negative thing, right? This one, we're multiplying an odd number of negatives. There's only one. So I know my answer is negative. We'll make that negative now. And then I identify how many decimal place values there are. 1, 2, 3, 4, 5, 6, 7 decimal place values. And then I treat these as though there were no decimals. So I would actually multiply this as 70,077 multiplied by just 5. And then whatever I get, I need 7 decimal place values in the end. So 7 times 5, that's 35. That's going to be 38 right there. 5 times 0, 0. 5 times 7 is 35. So I end up with 350,385. But I need 7 decimal place values, right? 1, 2, 7. And again, on this one, I've only got 6 numbers to work with, so I'm just going to tack a 0 on the left there to make it 7 place values. Which means my final answer there, that's where the decimal would be with the 0. But it's negative 0.0350385. But again, I'll put that in the calculator. So yeah, the calculator confirms that we've done that correctly. I'll just box it in. All right, you guys take 1 minute and try this one. 1 minute, go. We'll go over it. I don't think that was enough time for you guys. Now, to show this one, instead of using the exponent, I'm going to write this out as repeated multiplication. So negative 5.03 times negative 5.03. And again, you may just notice to start out that we have an even number of negatives being multiplied here, which makes the answer a positive. And again, once I know it's a positive, I don't really need to worry about the negative thing. But we do have decimals here. How many decimal place values are being multiplied? 4. We got the 0.3 and the other 0.3. That's 4 decimal place values. But then we can multiply this without any decimal place values. 503 times 503. Because we'll apply those place values of the decimals once we get this product. So let's do the work here. So this would be our product there, 253,009. But again, we need the 4 decimal place values from the beginning. So 1, 2, 3, 4, which means our decimal place value would be between the 5 and 3 there. So it ends up being positive 25 and 3,009 10 thousandths. But again, we'll go to the calculator just to double check. And that looks pretty good. That it is positive. So I'll box it in. So that was all multiplication of decimals, right? But let's look at some of those applications, particularly with area. So we got area of rectangles, which is just length times width. And then triangles, you can have 1/2 times the base times the height. Of course, I mean, since we're working with decimals, you could say, well, it's 0.5 times the base times the height as well. It's the same thing. And that's for a triangle. Now we got area of circles, that's pi times radius, or pi times radius squared, but they're probably going to tell us to use 3.14 as pi. Now, the reason why I have to clarify that is because there is a pi button on the calculator. Like the TI-30, you can see it's right there on the screen. And if you just push that button and then push enter, it'd say, well, there's pi for you, buddy. And well, if I wanted the decimal, then I push this arrow button, and it shows me a big decimal right there. Okay. Now, it's rounded that because this is an irrational number, so the decimal goes on forever. But again, for this class, generally they'll tell us to use just 3.14 instead of using the pi button. We're only talking about rectangles, so if I had a rectangle like this, okay. Now, if in the past when we were like, hey, find the area of a rectangle, let's use, again, some kind of basic values to make this easier to understand, and hopefully this will help. Now, before we were asking for perimeter, we're asking for area now. Well, if, let's say this is in inches, not that it matters, 5 inches and 4 inches, right? Well, when we get the area, and we know that it's length times width, so it's just, if I were to use the formula, 5 times 4, bam, I get 20. But then we say that square inches business, right? Well, that means that if I were to split this rectangle up into smaller, right, squares, so let's say that I drew a good square right there. Well, that means it would have a side length of 1 inch. So each of the side lengths are 1 inch, right, because it's a square. That means there should be 20 of those inside of this rectangle. Now, again, I haven't drawn it proportionally, so it may not work so well. But it should need more than that. 1, 2, 3, 4. So I would divide each of these into columns of. See how I've got 5 columns on this. So I've got 1, 2, 3, 4, 5. That's because this length right here would be 1 inch. Each of these increments would be 1 inch. Well, then I would split the 4 inches up into its own rows, I guess you could say. And now I can go through this and count. Well, again, if I'd drawn this better, these would all look like squares. But this would be a 1 inch square. This would be a 1 inch square. And if we counted all of them, right? So there's 5, 10, 15, 20. 20 squares. Well, what size are the squares? They're all in inches. So that's 20 square inches. So to start out with the area of a rectangle, we have a height. You could say that's length or width. Doesn't really matter. The height of 6.72 centimeters and a length of 4.42 centimeters. Now, again, I don't know if it helps, but, if you struggle with this stuff, sometimes a lot of students say that drawing the pictures does help. So I do recommend it, but would say that the height is 6.72, and no, it doesn't matter if this is proportionally, guys. 6.72 centimeters, and then the length would be 4.42 centimeters. So, something like this. Well, the area is just multiplication of the length and width. So I would take 6.72 and multiply it by 4.42. Now, since this is an application, I'm not really worried about doing it by hand. I've shown the work here, though, and that's the important part, is that we do show the work. But I can just put this in my calculator now as 6.72 times 4.42. And you could use the parentheses like I've done in the problem there. I typed that incorrectly, so let's fix that. And it gives me 29.7024. Now, that's not really a ton of writing on that. So I would just keep this as the decimal that we have. Also because it did not tell me to round. On the homework, I believe it may tell you to round to either the tenths or the hundredths. But since this one didn't say either way, I'm not going to round it. I'm not going to worry about it because 4 decimal place values is not too much. Now, this isn't the answer though, okay? Like we've said in the past, this is a word problem, so we do need to apply a label for this one. Now, the label is, I mean, if it's just perimeter, right, that's a length, we'd say, well, that's in centimeters. And that looks pretty good, okay? But area is two-dimensional, so generally we put a 2 right there as an exponent for the centimeters. Because really what we did is we took centimeters and multiplied it by centimeters, which means it would be centimeters squared as simplified multiplication. Now you could have written it as 29.7024, and then you could have written it as square centimeters. And you just get to choose whichever way you want to label it. Again, on the homework it should be labeled for you, but in the future it wouldn't be. I do like the square centimeter thing because it does clarify that there actually are centimeters or squares with side lengths of 1 centimeter inside of this rectangle. And that a little bit further. So what that means, like, if I were to say, well, let's go into this rectangle that I've drawn, right? Well, there'd be 1, 2, 3, 4, 5, 6. That's not great. Sorry, I couldn't draw this very much better, but 1, 2, 3, 4 right here, right? So what it's saying that if I actually split this up into squares, and you'll have to forgive my drawing, like if I were to draw this in squares, that I would actually have in that rectangle 29.7024 squares inside that rectangle. Now, again, my drawing is not great. Maybe it is bad. I don't know. But like if we were to go in and count these, well, these would be partial squares here, and these would be partial squares, so that all of these ones, that should end up being around, well, what is that, 24? And then these other ones here on the edges, those ones would add up to another 4.7024 squares. This power of 2 does not apply to the number. It actually only applies to the label on this one, which is in centimeters. And again, the 2 kind of indicates that it's two-dimensional, right? Length and width. But if we wrote it out like this, hopefully this makes a little bit more sense where it's in square centimeters, because both are valid ways to write the label for this one. So we have here the area of a triangle with a base of 9.2 feet and a height of 7.7 feet. Again, who knows what it would look like, maybe something like this. So we're saying the base here is 9.2. There we go. And then the height, again, it needs to create that 90-degree angle with this height, which is this purple line dashed, which it says is at 7.7 feet. Now, you don't really have to write feet like it's shown there. You can use this, I think that's an apostrophe mark, right? So you can use apostrophes to demonstrate feet like we've shown here, okay? Now, going back to the formula for this one, the area of a triangle is 1/2. Now, I'm just using the decimal value of 1/2, just because this module is in decimals, times the base, which in this case is 9.2, and multiplied by the height, which again in this case is 7 7/10. Well, for me, this is, since we're looking at an application here, I would just type this into the calculator, and the calculator shows me 35 42 hundredths. But again, we do need to label this one And since we're looking at feet, it's not just feet, it's in square feet. Yeah, let's show that actually with the power of 2 on the feet. So yeah, you could have written it like this one here as well, and again, it means the same thing. All right, find the area of a circle that has a diameter of 8 inches. So before we go over this one, let's look at a circle, okay? Let's see, I'll use the technology to make this a better circle than I could draw myself, okay? So that looks pretty good. There's a good circle. So parts of a circle, assuming that's the middle of the circle, that's just the center right there. And yeah, we do call the center. So that is a technical term, I suppose. Well, you got a few other parts of the circle that we look at, okay? The first one is the diameter. So the diameter, it stretches from one end of the circle to the other, but it has to go through the center. So that would be something like this. Okay, this red line would be considered diameter. Diameter. The other length that we need to be aware of is the radius. So the radius, it goes from one end of the circle to the center, like this. So this would be called the radius. Now, since the diameter stretches from one end of the circle to the other, but it goes through the center, the radius, we can see, since it only goes to the center from one edge of the circle, it is only half of the diameter. The last thing we'll need to remember is circumference. Circumference is also the perimeter of the circle, so it really is just the black line that goes all the way around this thing, all right? Now there's a formula for circumference, which we'll get into, but as far as I remember, you guys don't need to memorize those formulas. But if you did, that'd be good too, all right? Now this one says we want the area of the circle, okay? Now, again, we don't need to worry about how to find the area of the circle or where the formula comes from, but we're going to say it's pi times radius times radius. Now, if you use radius to the power of 2 because you're using a calculator, that's fine. Okay, but I'm going to use radius times radius just to emphasize the point. Okay, and pi on this one, again, just so we don't have to worry about the rounding stuff, I'm just going to say that pi is 3.14. Okay. Now, on this problem, it said that the diameter, try to color code that, the diameter is 8. Well, the area of a circle is written in terms of the radius. So, to find the radius, like we said before, the radius is going to equal the diameter, which in this case is 8, but we need to cut it in half. And that would tell us the radius, 8 divided by 2 is 4. So in this case, what is that, 4 inches? So the radius is 4 inches, so I got 3.14 times 4 times 4. All right, and again, I'm just going to go straight to the calculator to do this calculation. And if you wanted to put in 4 to the power of 2, again, that's fine. It's not going to change the answer, but this one's already rounded for us, which is nice. It came out as 50 and 24 hundredths. But again, we do need a label, and it's area, so it's still in squares. But in this case, it's in inches squared. So again, if you wanted to write it as 50.24 square inches, you could. Either one of these would work. All right, circumference of a circle. Oh, there we go. So I guess we're going to talk about it real quick. This is a nice formula for it. Pi times 2 times the radius. And some of you guys may notice that 2 times the radius is what? Well, that was the diameter. So we could say, if it was written in terms of the diameter, you could just do pi times the diameter. Because 2 radius is, or 2 times the radius, 2 radius, or 2 radii, is actually the diameter. So circumference equals this pi times the diameter. Now on a side note, just so you guys understand, like the value of pi, it eluded mathematicians for many millennia. And they could have found pi if they just had taken the circumference of any circle and divided it by the diameter. This is kind of like distance equals rate times time thing, and we can manipulate that equation as much as we need, but pi comes from this formula, and all circles are, well, they're kind of proportional to each other, right? Because it's a circle, kind of like a square is. None of that is important, really, but if you were interested in it, maybe that was nice for you. So we got the two formulas for circles, depending on if we have radius or diameter. It's the same thing. It would give us the same value either way. So on this one, find the circumference of a circle with diameter of 7 miles. Now, when we have diameter, we can say that the circumference of the circle is pi times the diameter. But remember, for pi, we're going to just be using that 3.14 business. So 3.14 instead of pi. And the diameter was given to us in this example as 7. So diameter of 7. Well, we'll multiply these in the calculator. 21.9821 and 98 hundredths. Now, circumference is just a perimeter, you guys. It's the perimeter of the circle. So where we've gotten kind of used to labeling our answers in square units, circumference is not square units. It's just a simple length. So this one was in miles. So it's just miles for circumference, okay? All right, here's some good applications. A standard toilet uses 1.2 gallons per flush. If a toilet is flushed 5 times per day, how much water will be used in a month? For 30 days, we'll say. All right, a couple things. First of all, I would just figure out, well, how many gallons per day are we looking at here on this? So for 1 day. Well, that's... So 1 day, we know that we got 1.2 gallons per flush, and then we're assuming 5 flushes per day. So let's look at that. 1.2 gallons per flush, but we're going to do it 5 times in 1 day. Well, I'll just go to the calculator on this one. 5 times 1.2. What does that give us? 6, right? So we end up with 6 gallons in 1 day. Well, we're saying that there's 30 days, so it's really 30 groups of the 6. So we'll multiply that by 30, and that will tell us how many gallons we would expect to have been used in a month. So 6 times 30, 30 days per month. Yeah, and we get 180 on that. I didn't even come out as a decimal. That kind of surprises me. So 180 gallons even, which I did not expect, but that's all right too, in 1 month. Now, I'm just writing 180 gallons. If you wanted to write 180 gallons in 1 month, that's fine. It obviously wouldn't be marked incorrect. But I don't like to write that much. I'm a lazy math person, so I'm going to just write gallons. Now, I just want to emphasize this too. If you guys are using calculators on this, I recommend the use of calculators because generally they're very accurate unless you type it in incorrectly like I did on the previous example. So do use your calculators, you guys. They're very, very good and useful tools.